Central Arizona receives on average 19 centimeters of precipitation annually that is distributed bimodally between winter frontal storms originating in the Pacific Ocean and short but intense summer monsoon storms. Since 2009, CAP has been monitoring the amount and chemistry of stormwater runoff in Indian Bend Wash, which drains a 240 square kilometer urban catchment. This greenbelt that you see in the photo, which was constructed in the 1970s, is a model system featuring multi-use green space, but designed to convey stormwater. In contrast to engineered stormwater conveyance, this novel design meets stormwater management needs while providing residents with recreational amenities and other ecosystem services.
Good morning. I'm Nancy Grimm with the School of Life Sciences at ASU. And for the water influxes, I'm leading the team that's studying stormwater in this watershed, Indian Bend Wash. It occupies a good proportion of Scottsdale. We have 3 ISCOs, or automated water samplers, in this site, in this watershed. The first one is here. This is the Lake Marguerite site. And the ISCO is behind me over here. And then we have another site further downstream called Silverado. And then finally we have a site at the almost at the end of Indian Bend Wash in Tempe at Curry Road, where there is a USGS gauge as well. And what we're trying to do is to isolate the chemical signatures from these different components of the watershed. So this one is largely residential landscapes. The infrastructure, the stormwater infrastructure, consists of a lot of retention basins, but also some natural desert washes that have been left intact when development occurred. As we go down, farther downstream, we see that the infrastructure becomes older and more dominated by retention basins, and then finally by street runoff and pipes. So this site is the Silverado Golf Course. This is one of 2 sites that we have ISCOs in the upper watershed of Indian Bend Wash. And here we have Quincy. He's actually servicing the ISCO, which is in this green box.
Hi, my name is Quincy Stewart. I'm a research specialist senior for CAP LTER. And the bubbler line is located right in the middle of the wash. So once the water comes through, and it's about 5 millimeters, the ISCO is engaged and starts to sample. Over here is the flood control pressure transducer, and we use this because it's online, because the data is on, I can access the data online. I use this to determine when to come up to the site and collect samples, so I know that the wash is flowing and it's not a wasted trip. Today I'm standing in a dry wash. On storm days, this would not be possible. You would have water reaching at least to the trees and in the greens.
Hi team, my name is Stephen Earl. I'm the information manager for the CAP LTER. And today I'm standing in the Indian Bend Wash, which is in Scottsdale, Arizona. So this is, as you can see behind me, this is a beautiful green belt. It's a kind of a mixed-use infrastructure, and we can stand in here and enjoy this facility right now. But during a storm, this place can fill up to several feet of water, and it becomes a flood conveyance system. So CAP has been studying stormwater chemistry, runoff, since 2009. In that time, we have monitored the chemistry of dozens of storms, and we're looking at things like nutrients, so nitrogen species, phosphate, total phosphate, total nitrogen, as well as conservative solutes like chloride, sodium. And what we're interested to understand is how things like land use and different types of stormwater infrastructure influence the chemical signature of stormwater flow, which has ramifications for downstream systems. And even though we've analyzed many storms, the patterns are not really clear. So we see some general generally similar behavior between reactive species like the nitrogens, phosphates, and then similar behavior among the non-reactive species like chloride and sodium. But there are so many factors that go into these patterns. Again, the different types of land cover, the stormwater infrastructure, things like season, that it's really a dynamic and interesting system.
One of the things we've learned from this work is that in arid land cities, streams located in more developed areas tend to be less flashy than those in rural areas. This is interesting because it's opposite of the patterns we see in more mesic climates. One possible reason for this pattern is that there are more places where water can be retained during storms instead of flowing directly to the stream. These places might be accidentally created or maybe engineered features like stormwater retention basins. In any case, our findings suggest that one-size-fits-all policies developed primarily in the more mesic eastern US may not be appropriate to managing stormwater in arid land cities.
Welcome to Orange Mall on ASU's campus. This mall used to be a street, and as part of the construction of the LEED Platinum ASU Student Pavilion, which you see there, ASU decided to repurpose Orange Mall from being car-friendly to being people-friendly. It's now a pedestrian mall, and a clear feature of this pedestrian mall are these bioswales. And so these bioswales were put in place to manage stormwater coming out of this part of campus on site. And so ASU decided to use urban ecological infrastructure as a way of managing stormwater on campus. To go along with the LEED Platinum certification of the Student Pavilion, ASU also wanted to get site certification for the stormwater management here. In order to do that, they had to come up with a monitoring scheme because sites requires evidence that the urban ecological infrastructure is actually working to manage stormwater. So we partnered with the Office of the University Architect came to us, we partnered with them, and we've been helping with the monitoring here at Orange Mall since 2018. A critical part of our monitoring here at Orange Mall is stormwater quality. We have 5 of these automated samplers, which are ISCO samplers as we call them, set up across the mall, and they are set up to trigger whenever a certain amount of water has accumulated in the bioswales. We've captured roughly 10 significant storms since monsoon season of 2018. This is the outflow from the bioswale system in Orange Mall. When the bioswales have filled up with sufficient stormwater runoff, they then discharge to this point where we use water level gauges and V-notched weirs to capture the amount of flow coming out of the bioswales. You can also see one of the tubes for one of our ISCO water samplers because we collect water quality here as well. A final aspect of our work at Orange Mall is we're interested in the ecohydrology of the bioswales themselves. We track soil moisture using these soil moisture probes that you see here. And we also use our infrared gas analyzer to quantify transpiration by the key plant species out here. That gives us an idea of water use by the plants, as well as their transpirational cooling potential to modify the microclimate.